Hello and welcome. My name is Vinita Ratan and I am presenting this assignment 1 of heat transfer to Dr. Shashikant Yadav, Assistant Professor, Department of Chemical Engineering, NIT, Jalandhar. So, let's start. The topic of the assignment is Buckingham pi theorem. Before we go, we will see the objectives of this video assignment. First of all, I will be discussing introduction of dimensions and units. Why dimensions and units? Because in the dimensional analysis, our main focus, our main concern is on the dimensions only. So, we will be discussing the dimensions and units, their introductions, type of dimensions and all other things. Thereafter, I will be discussing dimensional analysis. What actually the dimensional analysis is and how we can apply this method and how we can apply that concept and what are the different methods of dimensional analysis. We will also see an example and thereafter different applications of dimensional analysis. Also, then after we will see use of dimensional analysis in real life, where we can use the principles, the concepts learned in dimensional analysis, where we can apply all of the things we will see thereafter. Dimensional homogeneity. In dimensional analysis, we apply the principle of dimensional homogeneity. Also, so we will see that also in upcoming slides and different methods of dimensional analysis. Also like there are two methods, we will see in detail the different methods, their advantage, their disadvantage, and where we can apply which method. All other things we will see in this, and last we will see an example problem to explain the concepts. With the example, our concepts will be much more clear. So we will see an example problem at the end. Alright, so let's start. So this is dimensional analysis. Okay, so first of all we will see dimensions and units. So here the question is, why we need to study dimensions and units? Because engineers and scientists have to able to communicate not only with words but also by carefully defined numbers, numerical descriptions. So that's why we have to study dimensions and units. And what happened, like in dimensional analysis, we are only concerned with the nature of dimension, that is its quality, not its quantity. We are concerned about the quality of the dimension, not about its quantity. What does this mean? Like in dimensional analysis problem, we always try to reduce the number of variables in any of the physical problem. So that is written here that we are concerned about quality, not its quantity. Okay, we always try to reduce the number of variables. Okay, so it is correctly written over here in dimensional analysis. We are only concerned about the nature of dimension, that is its quality, not its quantity. Okay, now what the dimensions are actually? So dimensions are the properties which can be measured. So any of the probability that can be measured, okay, it called dimension. For example, we want to measure mass. So any object, so mass of any object, so mass is dimension. We can measure mass in kg, kilogram. We can measure mass in gram. We can measure in pound also. Like we want to measure mass, so we can measure it kilogram, in pound, or in gram, or any other units. So we can use mass. So mass is a dimension. Similarly, length we can also measure length in meter, in centimeter, inch, feet, etc. So it is also a dimension. Similarly, time, or there may be other dimensions like temperature also, and many other. Okay, so now what are the units? Units are the standard element we use to quantify these dimension. Okay, we use units. Suppose we want to quantify the mass. What we will see? We will use kilogram in mgs. We can use pound. We can use we can use gram. I have written here kilogram in mgs. Okay, so similarly for length we use meter, centimeter, kilometer, feet, inch, etc. So mgs it is meter. Similarly for time, it is second. If we take temperature, then it will be Kelvin or degree Celsius, depending upon type of system which we will see, which we will be using in our problems. Here I have write all them in mk system. And dimensions are actually of two types. One is fundamental dimensions and another one is the derived dimension. Okay, here we will see fundamental dimension, and in upcoming slides I will be discussing about derived or secondary dimension. So here fundamental dimensions are like mass. Its unit is kilogram in mgs. Okay, so of course, and its dimensions is m. Similarly for length, its unit is meter in mgs and its dimension is L. And for time, its unit is second and dimensions is T. If we take temperature, so unit will be like Kelvin and dimension we can use theta. Okay, or T we can use for temperature, the dimension is theta or T sometime also. So this is about dimensions and units and fundamental dimensions. Okay, in the next slide we will see secondary or derived dimension. So now secondary or derived dimensions. What are the secondary or derived dimensions? Okay, so the question is, what are the secondary or derived dimension? So it is written, secondary dimensions are those quantity which possess more than one fundamental dimension. Okay, one fundamental dimension means when fundamental dimensions are combined. When fundamental dimensions are combined together, we get secondary dimension or derived dimension. It is also called derived dimensions. Okay, we can call it secondary or derived dimension. For example, area. Unit is meter square, we know that, and dimension is L square. I will show you how this L square. Okay, so wait. So here area is equal to length into breadth. So breadth is also we can say L. Okay, so it is L square here, like that. Okay, so area is length into breadth. Wait. Area is length into breadth. Okay, so length we can use in L and breadth also in L, so it is L square. Alright, and for other also I will show you, just a minute, for others, just a minute. Okay, so suppose I take velocity. So for velocity, v is equal to distance upon time. So velocity is distance upon time, and we measure distance in L and time in t. So it is L t minus 1. Okay, which is written here. It's LT minus 1, this one. Okay, similarly for acceleration, just a minute. Okay, for acceleration, acceleration is velocity upon time. So velocity is LT minus 1 and time is t, so it will be LT minus 2, you can see here. Okay, and for the force, so formula of force is, wait a minute, sorry. Formula of force, F is equal to ma. Here m is mass and a is acceleration. So the dimension of mass is m, and acceleration you can see here L t minus 2. So the dimension of force is m L t minus 2. Okay, so for density, similarly for density, what is the formula of densities? Wait a minute. The formula of density is rho is equal to mass upon volume. Okay, so the dimensions of mass is m and volume is here we can see L3. So the dimension is ml minus 3. Okay, as it is written here. So these are the secondary or derived dimensions. Means when we combine one, two or more fundamental dimension together, we get secondary and derived dimensions like area, volume, velocity, acceleration, force, density, etc. They are a name of few. We can derive a lot of secondary dimensions from fundamental dimensions. Alright, so next is dimensional analysis. Now we are here with dimensional analysis. What actually the dimensional analysis is? Dimensional analysis is a means of simplify. Dimension analysis is a means of simplify a physical problem. So how we can simplify? By appealing to dimensional homogeneity, as I told you earlier also, that we use the concept of dimensional homogeneity in dimensional analysis. So that is written here. Dimensional analysis is means of simplifying a physical problem by appealing to dimensional homogeneity to reduce the number of relevant variables. Okay, means with the help of dimensional homogeneity, we try to reduce the number of variables in any physical problem. Okay, and it is pure mathematical technique. So one more point here note here it is a pure mathematical technique to establish a relationship between physical quantities involved in physical phenomena by considering their dimensions. Means what we will consider the dimension and will establish the relationship. Okay, all right, so it is a pure mathematical technique. Now what I have said, what is the objective of dimensional analysis? The objective of dimensional analysis is to reduce the number of parameters in a problem. What I have said, the objective of dimensional analysis is to reduce the number of variables or parameters in a problem. Why we want to reduce the number of parameters? For ease of calculation and experimental economy. Why? Because of ease of calculation. So we have to reduce the number of variables because of ease of calculation and experimental economy, and it follows that the best analysis will produce the minimum number of non-dimensional groups. So as these groups have physical significance, the non-dimensionalizing technique must always produce the correct scaling groups. Okay, and it might also be expected that the method of the dimensional analysis should be applicable to a wide range of problems. I'm repeating, the method of dimensional analysis should be applicable to a wide range of problems. It should be applicable wide range of problems. Okay, so right, and in short, if you want to say that the technique must be concise, correct and consistent, so it must be concise, correct and consistent. Okay, so the technique of dimensional analysis should be concise, correct and consistent. So this is all about dimensional analysis. Now let's see what are the different applications of dimensional analysis. So here I have listed down the some of the applications, like presenting and interpreting experimental data. Okay, so dimensional analysis, the concept, the method of the dimensional analysis is very useful in presenting and interpreting experimental data, and also in attacking problems not amenable to direct theoretical solution, means the problems that cannot be directly solved theoretically. For that, we can solve those problems with the help of dimensional analysis. Also, in checking equations, like again with the dimension homogeneity, we can check the equation whether an equation is valid or not. We can check with the help of dimensional analysis. Dimensional homogeneity and establishing the relative importance of particular physical phenomena, and last, physical modeling. So these are some of application of dimensional analysis. Now also a simple example to demonstrate these things. Suppose we have a smooth cylinder. Okay, wait a minute. We have a smooth cylinder. Sorry for the diagram. Smooth cylinder, and we want to know that the drag force F per unit length on this cylinder. Okay, on this cylinder will depend on what parameters. So we just want that the drag force per unit length on this cylinder will depend on what parameters, like the drag force per unit length on the cylinder will be function of F will be the function of airspeed U, density rho, diameter d, and viscosity mu. Okay, so the drag force per unit area per unit length, so the drag force per unit length will depend on airspeed U, density rho, diameter d, and viscosity mu. Okay, so however, instead of having to draw hundreds of graphs plotting its variation with all combinations of these parameters, like suppose we want to see the variation, then we have to plot different graphs like F with U, F with rho, or different graphs. So what dimensional analysis will help us that the problem can be reduced to a single dimensional relationship. Okay, now what is the relationship? This problem can be reduced to single dimensional relationship. Now what is that relationship? Okay, just a minute, I'm erasing them. Okay, that relationship is simply like, okay, CD is function of RE. Okay, so the dimensional analysis tell us that the problem can be reduced to single dimensionless relationship, that is CD is function of RE. CD is the drag force coefficient. CD is the drag force. Okay, and RE is, of course, we know that this is Reynolds number. So we have seen in this instant dimensional analysis has reduced the number of relevant variables. Like earlier we have 5 variables. Okay, we have 5 variables, 1 dependent and 4 is independent. But now here we have only 2 variables. So in this instance, dimensional analysis has reduced the number of relevant variables. okay, from 5 to 2, and also the experiment data to a single graph of CD against RE. Now if we want to plot, we want to see the variation, so we can get in a single graph, okay, CD versus RE. And before the dimension analysis, if we had to see the variation, then there were 4 available. So we have to plot 4 graphs, and so that that will be very complicated. So this is significance of dimensional analysis and applications. Okay, just a minute. So now what is the dimensional homogeneity? Now we will see what is dimensional homogeneity. So dimensional homogeneity means dimensions in each equation on both sides, okay, in both sides should be equal. So in any of the equation, the dimension on the both sides are equal, then we say that equation is dimensionally homogeneous. Okay, so actually the dimensional homogeneity is the concept where the dimensions of variables on both sides of an equation are the same. If the units are the same, the dimensions of each term must be the same, and every valid equation must be dimensionally homogeneous. If equation is not dimensionally homogeneous, we say that the equation is not valid. Okay, now what do I mean when I say that equations should be dimensionally homogeneous? That means all additive terms on both sides of the equation must have same dimensions. Okay, all additive terms on both sides of the equation must have same dimension. So here is an example is v equal to square root of 2gh, where v is velocity. So we all know that velocity is equal to distance upon time. So it is simply L t minus 1. So on the LHS left hand side, we are having dimensions LT minus 1. Now we will see acceleration. Now we will see on the right side here, 2 is dimensionless, of course, and g is acceleration. So the dimension is acceleration is, wait a minute, it is L t minus 2, okay, into h. So height, so the dimension of h is L, so it will be L2 t minus 2, and with square root of this, it is 2. So we will get this one is L t minus 1. Here we can see LT minus 1, and 2 is dimensionless. Okay, alright. So we have seen that in LHS part there are velocity and dimension is LT minus 1, and in RHS right hand side we get LT minus 1. Okay, that means the dimensions of LHS is equal to dimensions of RHS. So we can write it like that. Wait a minute. dimensions of LHS is equal to dimensions of RHS. Okay, so the equation V is equal to square root of 2GH is dimensionally homogeneous. Okay, so if the equation is dimensionally homogeneous, that means it can be used in any of the system of units. Okay, now next is methods of dimensional analysis. Okay, so the number of dimensional variables can be reduced in a smaller number of dimensionless parameters by several methods, and commonly used two type of methods. First is religious method and second is Buckingham pi method. Okay, so there are two methods for reducing number of variables. First is religious method and second is Buckingham pi method. Okay, now what are these methods and what are the procedure of these methods? What are the advantages and disadvantages? We will see. So first is religious method. The first method is religious method. Okay, so this method was proposed by Lord Relig. Okay, in 1889. In 1889, this method was proposed. Okay, in this method, a functional relationship is expressed in an exponential form, which is dimensionally homogeneous, as it is written here that also that functional relationship between variables is expressed in the form of an exponential relation, which must be dimensionally homogeneous. Like if y is a function of independent variables of x1, x2, x3 dot xn, like suppose y is any variable, dependent variable. Okay, y is any dependent variable which depend on independent variables x1, x2 and so on xn. So we can write it like that: y is a function of these independent variables. Y is equal to function f x1, x2 and so on xn. Now we can also write these variables in exponential form. Okay, we have to write these variables in exponential form, like y is equal to phi. Here phi is an constant. Okay, phi is a dimensionless constant, and we can write it in exponential form like x1 power a, comma x2 raised to b, comma x3 raised to c, and so on xn raised to z. Okay, now the procedure of religious method. So what is the procedure of religious method? First, write MLT form of the given data. Then we have write the same equation in exponential form. Okay, thereafter select suitable system of fundamental dimensions. After that, after writing the equation in exponential form, we have to select the suitable system of fundamental dimensions and then substitute dimensions of physical quantities. We will substitute the dimension of each of the physical quantities, and thereafter we will apply we will simply apply the dimensional homogeneity. Okay, so after that we will apply the dimensional homogeneity. Equate the powers and compute the values of exponents. So after that, equate the power on both sides, all kind of things. Now as I told you earlier, equate the power of equate the power and compute the values of exponent, and then substitute the values of exponents, and after substituting we will simplify the expression, and we will idle up to the three independent variables. We can it can also use for 4. Okay, now I take an example to demonstrate what I had discussed. Let's suppose a1 is an dependent variable. a1 is an dependent variable, and a1 is dependent variable, so and a2, a3, a4 and so on, an are independent variables. Okay, so here a1 is dependent variable, and a2, a3, a4 and an so on, an are independent variables in a phenomena. So the fundamental equation can be written as, wait a minute, the fundamental equation can be written as a1 is function of a2, a3 and so on, an. Okay, so this equation we can also write is an exponential form. After that we can write the equation in exponential form. Okay, using power a, b, c, so a, b, c, etc. So we can write it as, here a1 is equal to k, where k is any constant, a2 power small a, comma a3 power, this is 3, small b, comma and so on, an power n. Okay, we can write it in exponential form, where here k is the dimensionless constant. Now after writing in exponential form, what we will do, the dimension of each of the quantities of like a1, a2, a3 and so on, an are written, and the sum of the exponents of the functional quantities on both sides are equated. After this we will write the dimension of each of the term, and the sum of the powers will be equated, and then we will get the solution like the values of a, b, c, etc. Okay, so after solution, the equation, the values of the ABC and so on, so found out these values are substituted in the main equation. Okay, these values of ABC will be substituted in the main equation, and these values are substituted in main equation. After simplification yields dimensionless groups controlling the phenomena, and after the procedure we will get dimensionless number. Okay, so but what is the disadvantage of religious method? I told you earlier the disadvantage of religious method. Disadvantage of religious method is like when a large number of parameters are involved, this method become complicated. Like for 2, 3 and 4 variables, this is a known, this is we can use this method. The computation will not be much difficult but the large number of parameters are involved, then this method becomes complicated, and also religious method doesn't provide any information regarding the number of dimensionless groups to be obtained as a result of dimensional analysis. And one more disadvantage of this method is, like when we do dimensional analysis by religious method, okay, it will not provide, it will not give any kind of information regarding how many number of dimensionless groups will be getting after the analysis. So this is again a major disadvantage of this method. And when any disadvantage came, then we know we will shift to next method. So the next or the second method of dimensional analysis is Buckingham pi theorem. So this is the topic of our assignment, is Buckingham's pi theorem. So what is Buckingham? We can see here. So it is more generalized method of dimension analysis developed by E. Buckingham and others. They are most popular now. Others is most popular now. This arranges the variables into a lesser number of dimensionless groups of variables. Okay, because Buckingham used pi to represent the product of variables in each groups, we can call this method Buckingham pi theorem. Okay, so according to this theorem, if there are n dimensionless variables, like in any of the physical problem, if there are n dimensionless variables in dimensionally homogeneous equation described by m fundamental dimensions, and we can describe in m fundamental dimensions, then they may be grouped in n minus n dimensionless groups. Like we can write it like that. Here n dimensional variables, okay, and m is fundamental dimension, so we can describe then they may be grouped into n minus m dimensionless groups. Okay, so Buckingham referred to this dimensionless group as pi groups. Okay, this will be pi groups. So we call this Buckingham pi theorem. Now what is the advantage of using Buckingham's pi theorem? The advantage of this theorem is that one can be predict the number of dimensionless groups, okay, are to be expressed. Like in religious method, we were not able to find the number of variables, number of dimensionless groups after the dimensional analysis, or we were not able to predict the dimensional analysis. We were not able to predict that. But here in this method in Buckingham's pi theorem, we can predict the number of dimensionless groups are to be expressed. So this is advantage of using Buckingham's pi theorem. Okay, so if this is the statement of Buckingham's pi theorem. If n is total number of variables in dimensionally homogeneous equation containing m fundamental dimensions, then they may be grouped into n minus m pi terms. Okay, as I told you earlier, and then they can be expressed as function of x1, x2 and so on. Xn is equal to 0. Okay, then the functional relationship will be written as phi 1 pi 1 pi 2 and so on, pi n minus n is equal to 0. There will be n minus m terms, and the final equation is obtained in the form of pi 1 is equal to, pi 1 will be function of pi 2 function of other pi terms like pi 2, pi 3 and so on, pi n minus n. This method is mainly suitable for the variables where n is greater than or equal to 4. Okay, but this will be not applicable if n minus m is equal to 0. Means if the number of dimensionless variables and the number of fundamental dimensions are same, as we know the number of fundamental dimensions are the same, we cannot use the Buckingham's pi theorem. Okay, why? Because number of pi terms is n minus m. So when n minus m is 0, that means there will be no items. So we cannot use this method when n minus m is 0. Okay. Next is procedure of Buckingham's pi method. Okay. So first point is list all the physical variables and note n and m, where n is total number of variables and m is number of fundamental dimensions. Okay. Second is compute the numbers of pi terms by n minus m. Okay. Thereafter write the equation in functional form, and after that write equation in general form. Okay. So after that select repeating variables must have all the m fundamental dimensions and should not form a pi among themselves. Okay. So next is solve each pi term for the unknown exponents by dimensional homogeneity, and thereafter we will see an example of for forced convection, dimensional analysis for forced convection. Okay. On the basis of experience, it is concluded that forced convection heat transfer coefficient is a function of variables given below in the table. So the forced convection heat transfer coefficient is the function of these variables. Okay. First is fluid density, its symbol is rho and dimensions is ml minus 3. Okay. Second is dynamic viscosity, its symbol is mu and dimensions is ml minus 1 t minus 1. Third is fluid viscosity, symbol is v and dimensions is l t minus 1. Fourth is thermal conductivity, its symbol is small k and dimensions are m l t minus 3 theta minus 1. Fifth is specific heat, symbol is cp and dimensions is l to t. Okay, the last one is characteristic length, symbol is capital D and dimension is L. Okay, so therefore convective heat transfer coefficient is expressed as H is function of rho, mu, V, K, Cp and D, or we can write it like that, function of H, rho, mu, V, K, Cp and D equal to 0. Okay, here convective heat transfer coefficient is dependent variable. This one is dependent variable and remaining are independent variables. Okay, so the total number of variables here 1 2 3 4 5 6 7. So the total number of variables is 7 and the number of fundamental variables here, number of fundamental variables are 4. Okay, so according to the Buckingham's pi theorem, number of pi terms is given by difference of total number of variables and number of fundamental units. So here we can see the number of pi terms is n minus m is equal to 7 minus 4. So the number of pi terms is 3. Okay, these non-dimensional pi terms control the forced convection phenomena and are expressed as, we can express them as function of pi 1, pi 2 and pi 3 is equal to 0. Okay, so each pi term, next is each pi term is written in terms of repeating variables and one other variable, and to select repeating variables here this one repeating variables will be selected by following method. Okay, so for select repeating variables, following method should be followed. First is number of repeating variable should be equal to number of fundamental units involved in physical phenomena. Okay, thereafter dependent variable should not be selected as repeating variable. Okay, the dependent variable should not be selected as repeating variable. Okay, thereafter the repeating variables should be selected in such a way that one of the variables should contain a geometric property such as length, diameter or height, and other repeating variable should contain a flow property such as velocity or acceleration, and third one should contain a fluid property such as viscosity, density, specific heat or specific weight. Thereafter the selected repeating variable should not form a dimensionless group. Okay, repeating variable should not form a dimensionless group. The selected repeating variables together must have same number of fundamental dimensions. Okay, now two selected repeating variables should have same dimensions. Okay, so give 1 minute. So this is the procedure of repeating variables, how to select repeating variables. Okay, so the following repeating variables are selected from this method. The following repeating variables are selected. First is dynamic viscosity mu having fundamental dimensions m, l minus 1, t minus 1. Second is thermal conductivity k having fundamental dimensions m, l, t minus 3, theta minus 1. Okay, third is fluid viscosity v having fundamental dimensions l, t minus 1. Okay, fourth is characteristic length d having fundamental dimension l. So each pi term is expressed as pi 1 is equal to mu power a, k power b, b power c, d power d and h. Here a, b, c, d are constants. Okay, so writing down each term in above equation in terms of fundamental dimension. Here pi is dimensionless, so its dimensions will be m0, n0, t0, theta 0. Okay, the dimensions of mu is m, l, t minus l minus 1, t minus 1. Okay, power a, and the dimensions of k is dimensions of k m, l, t minus 1, theta minus 1, power b. Okay, dimensions of v is l, t minus 1, power c. Okay, dimensions of d is l, power small d. Okay, so last is dimensions of h is m, t minus 1, theta minus 1. Alright, so the comparing powers of m, we get here power of m is 0, here a, here b and here 1. So comparing the powers of m, we get 0 is equal to a plus b plus 1. We can write it like that, a plus b is equal to minus 1. After that, comparing the powers of l, here power of l is 0, here minus 1 into a, here 1 into b, and here 1 into c, and here 1 into d. Okay, or here the power of l is 0. So the power of L is 0 is equal to minus a plus b plus c plus d. Okay, after that comparing the powers of t, we get here the power of t is 0, here minus 1 into a, here minus 3 into b, here minus 1 into c, and here minus 3. Okay, so the powers of t 0 is equal to minus a minus 3b minus c minus 3. Okay, now comparing powers of theta, we get the power of theta here is 0, here also 0, here is minus 1 into b, here 0 0, and here minus 1. So we can write it like that, 0 is equal to minus b minus 1. So the value of b is minus 1. Okay, so substituting the value of b from equation 8 to equation 5 here. So substituting value of b from equation 8 in equation to equation in 5, we get a is equal to 0. Here we substitute the value of b is minus 1, so we get a is equal to 0. Now substituting the values of a and b in equation 7. Okay, this one is equation 7. Value of a is 0, value of b is minus 1. So the value of c will be 0. Okay, now substituting the values of a, b and c in equation 6. Here value of a is 0, b is minus 1, and c is 0. So value of d will be 1. Okay, so we have all these values now, a, b, c and d. So substituting the values of a, b, c and d in equation 4. This one is equation 4. Okay, so here substitute all the values. Value of a is 0, b is minus 1, c is 0, and d is 1. So the formula is pi 1 is equal to h d upon k. Okay, so the second pi term is expressed as pi 2 is equal to mu k power a, k power b, v power c, d power d, and rho. Okay, so here also pi 2 is dimensionless, so its dimensions are m0, l0, t0, theta 0. Okay, dimensions of mu is m l minus 1 t minus 1 power a. Dimensions of k is m l t minus 3 theta minus 1 power b. And dimension of v is l t minus 1 power c. Okay, dimension of d is l power d, and dimension of rho density is m l minus 3. Okay, now comparing the powers of m, we get 0 is equal to a plus b plus 1. Like that we can write it like that, a plus b is equal to minus 1. After that comparing powers of L, 0 is equal to minus a in plus minus b plus c plus d minus 3. Okay, like that. After that comparing powers of t, we get 0 equal to minus a minus 3b minus c. Okay, so here after that comparing the powers of theta, it is 0 equal to 0 plus minus b, 0 minus b, 0 0 and 0. So b 0 is equal to minus b, so the value of b is 0. So substitute the value of b in equation 13, we get that a is equal to minus 1. After substituting the values of a and b in equation 15, we get c is equal to 1. Alright, so after that substituting the values of a, b and c in equation 14, we get d is equal to 1. So here the value of a, b, c and d we got. So substituting the values of a, b, c and d in equation, this one, equation 12. So we get pi 2 is equal to mu power minus 1, k power 0, v power 1 d power 1 rho. Okay, so the formula is pi 2 is equal to rho vd upon mu. Okay, so the third pi term is expressed as pi 3. I will zoom it. सॉरी ये आई डोंट नो कैसे हो गया. पाई 3 इज इक्वल टू म्यू ए, म्यू की पावर म्यू रेज टू ए, के रेज टू बी, वी रेज टू स्मॉल सी, सी डी रेज टू डी एंड सी पी. Okay, so pi 3 is dimensionless, so its dimensions will be m raised to 0, l raised to 0, t raised to 0 and theta raised to 0. Alright, so dimensions of mu is m, l raised to minus 1, t raised to minus 1 whole raised to a. Okay, dimensions of k is m, l, t raised to minus 3, theta raised to minus 1. Okay, so whole raised to b. The dimensions of v is l, t raised to minus 1 whole power c. Okay, and d will be l raised to d. Okay, so c and after that cp. Here dimensions of cp will be l raised to 2, t raised to minus 2 and theta raised to minus 1. Here this they are powers. Okay, so comparing the powers of m, we get 0 is equal to a plus b. Okay, so a plus b is equal to 0. After that, comparing powers of l, we get 0 is equal to minus a plus b plus c plus d plus 2, like that. Okay, after that, comparing the powers of t, we get 0 is equal to minus a minus 3b minus c, or here minus 2. Okay, like that. After that, comparing the powers of theta, here 0 is equal to, here also 0, here minus b, 0 0 and here minus 1. So 0 is equal to minus b minus 1. Okay, like that. So we substitute the value of b in equation 21. So we get a is equal to 1. After that, substituting the values of a and b in equation 23. So we get c is equal to 0. After that, substituting the values of a, b, c in equation 22. Okay, we get d is equal to 0. Okay, so we get all the all the values of constant a, b, c and d. So substituting the values of a, b, c and d in equation 20. So we get a is equal to 1, b is equal to minus 1, c is equal to 0 and d is equal to 0. So the formula is pi 3 is equal to mu cp upon k. Okay, so substituting the values of pi 1, pi 3, pi 1, pi 2 and pi 3 in equation 3. So where is the equation 3? Equation 3 is, wait a minute, this one is equation 3. So substitute the values of pi 1, pi 2 and pi 3 in this. We get the value of pi 1 is the value of pi 1 is ht upon k. So here ht upon k. Now the value of pi 2 is rho vd upon mu. So here rho vd upon mu, and last the value of pi 3 is mu cp upon k. So here mu cp upon k is equal to 0. So we can write it like that: hd upon k is equal to the function of psi. Psi is any constant number, so the function psi is the function, psi bracket rho vd upon mu cp upon k. Okay, so here this one is nu, this one is re and this one is pr. So what is this nu, re and pr? So nu is wait a minute, NU is Nusselt number. Okay, NU is Nusselt number, and RE is Reynolds number. We all know that this one is Reynolds number, and the last PR is Prandtl number. Prandtl number. Sorry for that. Prandtl number. Okay. So NU is Nusselt number. RE is Reynolds number. PR is Prandtl number. Okay. So the above equation, this one, above correlation is generally expressed as this relation. We can express it like that: NU is equal to C RE power A PR power B. Here C, A, B and C are determined through experiment and they are constants. Okay, so wait a minute, I will erase it. Okay, so we have reduced the number of variables okay, from earlier. How many variables earlier? There are, wait a minute, there are 6 variables. Okay, and now we have grouped them into 3 dimensionless variables: NU, RE and PR. Okay, so this is the advantage of Buckingham's. So this is the advantage of dimensional analysis. Now the calculation will be easy. So this is all about dimension analysis. So, and that brings us to end. Okay, so thank you so much for your attentions. Thank you so much for listening. Thank you.